We would like to calculate the signed area of g of x equals -1/2 x plus 2 on the interval from 0 to 7. Let's go ahead and do that using geometry. And what I'm going to do is I'm going to graph this and then use geometry to find the signed area. If I graph the function g of x equals -1/2 x plus 2, in between 0 and 7, I get this line segment. Obviously, the graph of this function would go on forever, but I'm only concerned how it exists between the x value of 0 and the x value of 7, at least in terms of this problem. So what I'm going to do is I'm going to look at this and say from 0 to 4, this line is above the x-axis. So I am going to shade the portion of the line that's above the x-axis between 0 and 4. From 4 to 7, well, I would be looking at a proportion of my line that is below the x-axis. If I were to shade the region between the line and the x-axis, it would look like this. Now, obviously, this first triangle that I wrote out, that triangle is above the x-axis, so it's going to have a positive value. And the second triangle that I shaded, that's going to be below the x-axis, therefore that has a negative value. If I take a look at this left triangle, that's the one that's shaded in blue, the area of the left triangle is 1/2 base times height, since it's a right triangle, and the x values go from 0 to 4. That means the base is 4. And the height goes from 0 to 2. The base is 2. The first triangle, therefore, has an area of 4. Similarly, the second triangle, 1/2 base times height is the area. Base here goes from 4 to 7. That's a base of 3. And the height goes from 0 to -1.5. Again, if you look closely and map this over, that's -1.5. When you type in 1/2 times 3 times -1.5, you get a -2.25. I'm actually going to call this a positive 1.5 just so I'm consistent. 2.25 with what I've done in my previous problems. So I want to be consistent with what I've done in the previous problems, and in all the previous problems, I looked at these two triangles separately, and I would look at positive areas. When I throw that into the sign area, then I took into account the ability to have a negative value. So the signed area would be the blue triangle area, which is 4, plus a negative or minus the green area triangle, which has an area of 2.25. Therefore, when you take 4 minus 2.25, you end up with a 1.75. So the signed area in that scenario is 1.75. And that's the big takeaway from this chapter or from this section.